This example comes out of section 5.3, the tangent function. This example is our first introduction to a word problem using tangent. We're given the information that a small plane is flying at a constant altitude of 6,000 meters towards an observer on the flat ground. This is one of these questions that takes longer to write than to do, but the first thing we're asked to do is determine the relationship between the horizontal distance in meters from the observer to the plane and the angle in degrees formed from the vertical to the plane. So we'll draw a picture so that makes a little more sense. B will be asked to sketch the graph of d versus theta. We'll be asked where are the asymptotes and what happens when theta equals 0. So in classic math teacher style, I've got my art skills on display here. We have ourselves an observer on flat ground. We have a plane that's 6,000 meters up. The vertical is straight up, obviously. The horizontal distance to the plane is this, so we'll call that d. The vertical we know is 6,000 meters, so that's convenient. And the angle they're talking about is the angle from the vertical to where the observer is looking at the plane. So we have this. So the relationship, hopefully you realize, and I guess the fact that it's in the tangent function section, it gives it away a bit, but the tan theta is equal to opposite over adjacent, so d over 6,000. That would be a relationship between d and theta. In the second part, we're asked to sketch the graph of d versus theta, so we might write that slightly differently as d equals 6,000 tan theta. What you have if you graph this is basically just a graph that goes between positive 90 and negative 90 degrees, has asymptotes, and has a pretty serious vertical stretch of a factor of 6,000. So your axes here would, to even be able to see this graph, would need to be pretty big numbers on your y-axis, like positive, negative 10,000 or 20,000 or something like that. So a sketch would be fine there. We have distance in meters, and we have, our theta as our x-axis. Where are the asymptotes? I kind of just said that already. X equals 90 degrees, x equals negative 90 degrees. What do they actually mean is, if the ground is flat and the plane is staying at 6,000 meters, it's impossible for this angle to reach 90. You can draw this plane going as far to the left or as far to the right as you want, but that angle will never ever actually reach 90 degrees no matter how far you go, as long as the ground is assumed to be flat, which it is in this question. Now when they ask us explain what happens when the angle is equal to 0, it just means that this plane has flown directly overhead of the observer. So the plane is right above the observer at that instant when theta is 0 degrees. So it's exactly 6,000 meters away, but 0 meters horizontally. So the horizontal distance would be 0. And so I hope that example makes sense, and you'll have some word problems similar to that towards the end of 5.3.